Okay, so when you do this, then you get a radius of 7.3429 meters, but the question asks for circumference, so then you have to do 2 pi r. Okay, and when you do 2 pi r, you get 4.61366 times 10 to the negative 2 meters. Or you could say that is 4.61366 centimeters. Okay? Number 9. Number 9 has an arrow beside it, and then really the arrow is because of part B and part C. Okay, so the first part gives you a mass. It says it's doubly ionized, which means 2 charges are taken off. Gives you B, gives you R. Again, you're going to use R equals mv over qb. And this time it asks you, like it did earlier, to find speed. So V will equal R qb over m. So R 0.15 meters. Q is 3.204 to the negative 19 coulombs, and B is 2 teslas. And the mass 6.6 to the negative 27 kilograms. Okay? And when you do this, you get a speed of 1.4564 to the positive 7 meters per second. So that's A. But B then asks you, what is its kinetic energy? So we know kinetic energy is equal to 1/2 mv squared. So 1/2 the mass, 6.6 to the negative 27 kilograms, and then the speed that you just found and have in your calculator with all of its digits, 6.4 to the positive 7, and don't forget to square it. So when you do, you get a kinetic energy of 6.9993 to the negative 13, and remember energy is measured in joules. And then the last part wants to know the potential difference. What potential difference would be required to give it this kinetic energy? So we go again to that equation that we've seen a couple times now, once last week and once before. V equals W over Q, because remember W is equal to the change in energy from grade 11. We're assuming it's starting out at 0 and that this is its final, right? Final minus initial. So it'll just be 6.9993 to the negative 13 joules divided by 3.204 to the negative 19 coulombs. And when you do this, you get a voltage of 2.185 times 10 to the 6 volts. Okay, so that's it from your textbook. The other thing that you had was some of these multiple choice questions. Okay, so I had asked you to do numbers 12 through 15. And 12 through 15, 12 through are based on this up here. Okay, so it says base your answers on this. There's which represents a cross-section of the operating solenoid. So there's a battery hooked up to it somewhere. And it says a compass is located down here at point C, which is what's telling us that we have a north and a south here. So the first 12, which diagram best represents the shape of the magnetic field around the solenoid? Well, please don't pick this one, because it's has to look like a bar magnet. So it either needs to be number 3 or number 4. And you need to remember that field lines always come out of the north and go into the south. So here they're not coming out of either. Here they're coming out of the north on the bottom, but they're coming out of the south on the top. It can't be that one. So it has to be choice 3. There's that better. Okay, it has to be choice 3. All right. Number 13 says, which shows the direction of the compass needle at point C. So you place a compass needle here, and the compass needle points in the direction of the field lines. And we just picked the field lines to be going at point C to the left, right? Because the compass needle always points to the south pole of the magnet. And so it must be choice 4. Okay? Number 14, if B is the north pole of the solenoid, which diagram best represents the electron flow? So we go back up here. This has to be electron flow, so use your left hand. And your north has to be over here on this side, and so it's going to flow down going up in the front. Sorry, I have it expanded. My hand looks like a giant. Okay, but it has to be going in at the top and out at the bottom. So which one of these is in at the top, out at the bottom? Again, don't pick these two because they're both going the same way. In at the top has to be this one, out at the bottom. Okay, so number 14, choice 4. And then number 15, if the current in the solenoid is doubled and the number of turns is halved, what would happen to the magnetic field strength? So we had said that the field would get bigger as Q got bigger, as I got bigger, and it should make sense that it'll get smaller as the number of turns gets smaller. So if one is doubled and the other is halved, it should stay the same. Okay? And so that was all of your questions. You can do the back side, some of the back side if you want. You can do questions 16 to 20. Okay? So while you're on this sheet, if you want to do 16 to 20, you cannot yet do 21 to 23. So stop at number 20. Okay, and then the other thing I'm going to have you do for homework, I will post the sheet. Just going to, if I can, make this smaller. Okay, it's called Magnetism and Electrostatics question. I already have it copied for you, but I'll attach it to our group. And I'd like you to do questions 1 to 4. I'd like you to do questions 8 and 9 because they're hand rules. And I'd like you to do the very last two, 15 and 16, which are going to be with the new equation, which I'll do a separate video on. Okay? Thank you. See you soon.